Hey sixth graders, this is your reteach session for energy transformation. Now it's very important that you understand how you're going to get credit for this reteach, so a couple things we want to think about. First off, please make sure that you are taking notes while the video plays. Hopefully your teacher gave you a blank sheet of Cornell notes that's specific for this video. If they didn't, or if you've lost it, this is okay. You can use your own notebook paper, that's fine. It's also okay to use your own notebook paper if you need more space on the worksheet that your teacher gave you. Now also, please make sure that you are following all the instructions in the video. If the video asks you to write down or to work out an example, it is expected for that to be done on your notes. Failure to do so might make it so your teacher has you repeat this process. Please make sure you're listening and looking for all directions. When you're finished with your notes, please go ahead and show those to your teacher. Only your teacher can give you credit for this reteach session. Once you have credit for the reteach session, your teacher will tell you how you can do the reassessment, and hopefully that'll make sure that you now fully understand the topics for energy transformations. All right, let's begin. Now, before we get going too far into this, remember this is a video, so please pause it anytime you feel like it's going too fast. You can always back up, and also pause it anytime that you're trying to practice problems before the answers pop up. You know, the answers are there just to make sure you're checking your work. Don't rely on the answers. If you have to rely on the answers, then you definitely don't know this. You should be using them to check your work, not just to fill out your notes. All right, so if we get to thinking about the different types of energy, and this is only a short list, but some basic types of energy. You got things like thermal energy. A lot of times we associate that with heat. We feel heat. Other times there's chemical energy. Chemical energy is going to get associated quite often with batteries. We have radiant energy. Most often we're thinking of radiant energy traveling through space. This is like energy coming from the sun traveling to the earth. We have electrical energy. A lot of times you're just thinking of the electrical outlets in your house. We have sound energy. Even you being able to hear my voice, there has to be energy for this to happen, to travel to the microphone on the computer. We have mechanical energy. For mechanical energy, I always think about parts in a machine that are moving. That seems to help me out the best. And we'll go over some examples, but a lot of times this could be as simple as gears turning inside a food blender. That's when we're thinking mechanical energy. Now, it's also important that we think about on Earth, most of our energy transformations could be traced back to the sun. As far as we're concerned, this is the original source of energy for life on our planet. So let's start with a really simple energy transformation. Remember, when we say transformation, we just mean that it's going from one type to another type. It might be doing this once, it might be doing this multiple times. So a really simple example of this is sunlight, which we'll consider radiant energy. As this radiant energy shines down onto your face when you're outside, you start to feel the warmth of that energy, and we can now say that it's changed to thermal energy. So it started as radiant energy, now it's making you warm, so it's thermal energy. This is a very simple one transformation. Now, most and some energy transformations really take place in complex chains, so it'll change more than once. And we'll try to give you a few examples, and if you think back to the work that you have that you've already done, you'll see a lot of those examples as well. Let's start with a popular example for something that's a little more complex. Let's think of battery-powered alarm clock. So in this battery-powered alarm clock, the hands move and an alarm rings when it's time to wake up. Now we're going to do a complex example here, but on your notes, go ahead and take some notes and think about what kind of energy transformation this may be. Now it's early on, so I'll definitely help you with this one as well. So if we could just use a starting point, let's use chemical energy as a starting point. We have chemicals in the battery. Those chemicals are basically storing energy and they're waiting to be used. And this alarm clock is going to use it. So this chemical energy is going to transform into something else. And that would be electrical energy. So this is actually the chemicals in the battery are now giving electrical energy to the clock. That's a transformation. It's gone from one type of energy to another type of energy. So after we get electrical energy, now we actually have hands on the clock that are actually moving. There's pieces inside of the machine that are moving. Now that electricity has transformed into mechanical energy. And then the last problem on this one is it said the alarm rings. So in this style alarm clock, it's kind of like when the hands go back and forth and it hits the bells on top. So that mechanical energy is now producing a sound. So that's our energy transformation. If we think about this example, the energy began with chemicals in the battery. The battery turned it into electricity, so it's electrical energy. That moved the hands on the face of the clock as well as the hammer hitting the bells, and that gave us sound energy. That would be a more complex energy transformation. Let's try another one. Please make sure you put this example in your notes as well. So for a solar powered car, that's all I have to write for my notes. And then the next thing I want to write on my notes is that energy chain, just like we had on the bottom of the last screen. So for a solar powered car, most cars run by using a battery for electrical energy and gasoline for chemical energy. A solar powered car runs using only energy from the sun. All right, so let's try to put the chain together into our notes here, see what we can get. The first clue that it gave us was it was energy from the sun. So we're going to say that's radiant energy. Now once again, if I'm going too fast, go ahead and pause the video. So if you need to, pause the video and think about what would probably come after radiant energy for the solar car and see if you can get it before I show it to you. Alright, so after the radiant energy, the sun has made it down, it's shining onto the solar car panel. Now those panels are going to turn it into electrical energy. So it was radiant energy, that transformed to electrical energy. So what would have to come after electrical in this case? Well, in this case, we're going to actually have the car start to, the motor's going to be turning, the wheels are going to be turning. So we have parts inside the machine that are moving. So at this point, it's going to be mechanical energy. So we had radiant energy from the sun, turned into electrical energy when it hit the solar panels, and then that transformed into the mechanical energy. All right. So here's something to think about. If you really think about this, it's true, but it's a lot to think about. This is an important idea. You're going to use this in 8th grade years as well as many other years in science. But an important thing to understand is, in general terms, energy cannot be created, and energy can also not be destroyed. It can only be transformed from one form to another form. So if you think about this and you're sitting there thinking, well, now, wait a minute, that's not necessarily true. Didn't I use all the power in my cell phone once, and didn't I destroy all the energy in the battery? Well, the answer to that is no, you really didn't. The energy has flowed from your cell phone, it's been used, and it's been radiated out in other forms. That energy is still out there, it just changed what it was. And this is true for any example. So if you think about it, identify all the energy transformations that occur when you operate a hair dryer. So go ahead and try a hair dryer. On this one, just try it like we did before. Write the chain at the bottom. What would be the types of energy involved with the hair dryer? I'll give you a clue. Go ahead and start with electrical when you plug the hair dryer into the wall. All right, now for that hair dryer one, we're just going to let you see what you get. So make sure you have that in your notes. Your teacher's going to be looking to see how you did on the hair dryer one. But that one, we're going to let you try that on your own. Plus, if you think about it, you've seen it in the work you've done before. Now, let's keep thinking on energy. There's other types of energy. You just got done with a unit studying potential and kinetic energy. This is why it was so important that you understood that, because now it comes back again already. So if we think about a pendulum, if we hold on to the pendulum at position number 1, we're just hanging on to it, it's not moving yet. Try to think, what has to be that type of energy? And if you thought potential, you're absolutely perfect. It's potential energy when you're just holding on to the pendulum at position 1. Now when I release the pendulum and it starts to fall, as it falls through these other places and it's moving, that's energy in motion, and that takes it back to kinetic energy that you studied before. So an important concept that's going to come up quite a lot is, if we think about it, where on this diagram, and go ahead and put this diagram in your notes if you haven't done so, pause it if you need to, but where in this diagram would we have the potential energy starting to first turn into kinetic energy? That's a big question, so let me make sure I say it again. At what point on this diagram do we have potential energy starting to transfer to kinetic energy? All right, so if we go over this again, you're holding onto the pendulum at point 1, you release it, and the pendulum starts to move until it finally comes to a rest. So to answer our question, at point 1, it was all potential, and there was no kinetic energy at all. But as soon as I let it go, the potential energy starts to turn into or transfer to kinetic energy. So the answer to our question, where is it that we have potential energy turning into kinetic energy, would be between points 1 and points 2. So between 1 to 2 is where we see potential energy turning into kinetic energy. If you got that, excellent job. That's a tough idea. All right, please go ahead and write down this example in your notes as well. A flashlight is actually the one that the state of Texas most commonly associates with energy transformation. So this is a great one to think about. So if we pretend like we were doing a lab, or if you want to try this at home, if you got a battery-powered flashlight, go for it. If you've got a flashlight and the batteries are inside of it, and then you turn on the flashlight, we should be able to figure out these blanks. Blank energy was converted to blank energy and then blank energy. All right, go ahead and pause the video if you need to, but fill out those blanks. See what you can figure out. Okay, so now that you're back, if we think about this, we had chemicals that were inside of the battery. Once again, those batteries are just holding those chemicals. It's storing up the energy. It's getting ready to use them. Now, please understand the batteries do not create energy, because remember, we can't create energy. We just said that a little bit ago. It's just storing the energy. So if anyone ever says they're creating energy, they're using their words wrong. It's actually a false statement. The chemicals are stored in the battery. It's storing the energy. So chemical energy was converted to electrical energy. So now the flashlight actually has electricity to use from that stored up chemical energy. And that electrical energy was then produced to light energy. So now the flashlight is actually shining. So there you can see the process of energy transferring from chemical to electrical to light. Very popular example. All right, so let's try 2 more. For a food blender, think about a food blender and a campfire. Go ahead and pause the video, and when you've got all of the stuff done, when you got your chain made for what you think that energy transformation is in your notes, go ahead and play it again and check your work and see if you're right. All right, let's do a food blender first. So if we're using a food blender in the kitchen, once again, this blender needs electricity, so a good starting point would be electrical. Now, if you're thinking, I got a really cool battery-powered food blender, could I have chemical first? Sure, you could. That'd be fine. But if it's just a traditional food blender that you're plugging into the wall, let's start with electrical. That's going to turn the blender part on the bottom. That's going to really start to grind up the food. So that's mechanical. And there's a lot of things you could put after this, but sound would be a great pick for after mechanical. Food blenders are pretty loud. That would be the flow of energy. Electrical transforms to mechanical, transforms to sound. Now go ahead and check your work for campfire. Pause it again real quick if you need more time to do campfire. For a campfire, once again, if we're burning logs, that is chemicals that are stored up in the logs that are being ready to use. And then we would have some radiant energy that would be coming off of the burning, and then we would feel the thermal heat on our faces. So chemical to radiant to thermal. All right, so here's some critical questions. I want you to write down each one of these and try them on your own. However, we will not go over the answers for these. Although if you've been paying attention, we've gone over a couple. So for these, make sure these are on your notes so your teacher can see them. So pause the video if you need more time. For the first one, what energy transformation takes place inside a working battery? Go ahead and write that question in your notes and then write your answer. Next one. How about in your cell phone? Is there any energy transformation you can think of that your cell phone would use? Please write that in your notes and your answer. Next one is a flashlight. What kind of energy transformations take place inside of a flashlight? Once again, make sure this is in your notes along with your answer. How about a hand crank flashlight? You talked about these in class, but this would be one that necessarily, it wouldn't have batteries per se. You could just kind of crank it. I'll give you a clue. There could be like a little generator in there that when you crank it, that would help the flashlight light up. That'll help you out with some of the parts. And then what about a car engine? Think about all the different energy transformations that take place in a car engine. If you're not sure how a car engine works, this would be a perfect time to ask your parents for help. Now, even if they don't know all the inner workings of an engine, that's okay. They'll know the basics and they can help you out. They'll give you clues as to how the gasoline enters into the cylinder, and then the spark plug is going to ignite something. They can give you help there if you need it. And then what about your body? I'll give you a clue. If you're stuck here, think about when you eat lunch. And other times, there's a lot of energy transformations that happen with your body. This will be a huge topic when you hit 7th grade next year. All right, so make sure you have those all in your notes. Now, this part's important as well. Your teacher is going to look for this code word on your notes. This guarantees them that you stayed through the 16 minutes of the video or so. So somewhere on your notes, either at the top or the bottom, make it really obvious, but make sure you write "Go Tigers." This would be a great way for your teacher to know that you stuck it out, you did the reteach, and that you took your notes and you're ready for your next reassessment.